Hello everyone, my name is Alex and today I'll be your guide to the world of encryption and hash function. Okay, here's an overview of this presentation. In the introduction section, I will give you guys a quick introduction to encryption and why we need it in our life. And in the second portion of the presentation, I will talk about symmetric and asymmetric encryption, as well as their differences, their strengths and weaknesses, and their application. And the final part of the presentation is I'm going to talk about the hash function. Many people get mixed up a hash function with encryption, but it is not. I will explain the difference later. Now let's get started. So, what is encryption? Encryption is the process of encoding a message or information in such a way that only authorized party can access it using key or multiple key depending on the encryption scheme you are using. If you look at this picture on the right hand side, it is showing the famous Caesar cipher. It is a very simple encryption scheme. You simply shift the alphabet to the left 3 letters and there you go, you have an encryption. See, T become W, R become U, and E become H, and so on. Obviously you cannot use this encryption scheme to protect your information on the internet. It will be broken within seconds. As to why we need encryption, well, the simplest answer is we need to protect the sensitive information on the internet. For example, the sensitive information could be your credit card number, your medical record, your transaction history. For businesses, it could be their financial information, their user information. For example, encryption is absolutely essential in the age of internet. So there are two main types of encryption: symmetric encryption and asymmetric encryption. Each have different uses, their strengths and weaknesses and application. I will explain this concept in the next slides. So we are here. We are going to talk about symmetric encryption, also known as secret key encryption. I'm going to use the two terms interchangeably during the presentation, so don't be confused. So what is the definition of symmetric encryption? It's a type of encryption where one key is used for both encrypting and decrypting. It is one of the oldest and well-known technique in encryption. It's used a secret key in an encryption algorithm to change the content of the message in a particular way. Only the sender and the recipient who have the key can encrypt and decrypt all the messages. So there are several popular symmetric encryption algorithms: AES, Advanced Encryption, Standard, RC4, Flowfish, and so on. If you look at the picture on the right hand side, you see the plain text message, "Love you Granny." It went through an encryption algorithm with a shared key, then turned into a jumble of words that human cannot understand. And during the decryption process, it went through the encryption algorithm again with the same key into the plain text. So, what are the strengths and weaknesses of symmetric encryption? The strength is it's one of the simplest encryption scheme because this is so simple. It is fast and uses less computer resources, and it prevents widespread message security compromise. If a different secret key is used for communication with every different party, if a key compromise, only messages between a particular pair of sender and receiver are affected. Communication with other people are still secure. However, when we come to the weaknesses, this is one of the biggest weaknesses of symmetric encryption, is that it needs a secure channel for key exchange. Sharing the secret key in the beginning is one of the biggest problems in secret key encryption. It has to be exchanged in a way that ensures it remains secret. Another problem is key management. A new shared key has to be generated for communication with every different party every time. This creates a problem with managing and ensuring the security of all these keys. Another problem with symmetric encryption is there is no way that you can guarantee the origin and the authenticity of the message because it does not carry with the metadata necessary for such an operation to occur. There are several notable applications of symmetric encryption. Mostly, it is the best kind of encryption scheme to use to encrypt your own data. For example, you can use it to encrypt your own database. And hard drive encryption. There's no need to exchange any key because or random number generation and hashing. On to the next topic, we are going to talk about asymmetric encryption, also known as public key encryption. The definition of asymmetric encryption is that it encrypts and decrypts the data using two separate yet mathematically connected keys, the public key to encrypt and the private key to decrypt. Several famous algorithms are RSA. It is the most popular asymmetric encryption algorithm, ECC, LGAMO, and DSAs. One example of asymmetric encryption would be, say, Alice wants to talk to Bob. They establish a chat section. Bob will have to send his public key to Alice, and Alice will use that key to encrypt her message and then send that message to Bob, and Bob will use his private key to decrypt the message. The strengths and weaknesses of asymmetric encryption. Asymmetric encryption is very convenient. It solves the problem of distributing the key for encryption. Everyone publishes their public key and private key are kept secret. It provides for message authentication. Public key encryption allows the use of digital signatures, which enable the recipient of a message to verify that the message is truly from the particular sender. And detection of tampering. The use of digital signature in public key encryption allows the receiver to detect if the message was altered in transit. A digitally signed message cannot be modified without invalidating the signature. And non-repudiation. What the non-repudiation mean? It means that digitally signed message is akin to a physically signing a document. It is an acknowledgement that the message, and thus the sender cannot deny it. There are several weaknesses that come with the asymmetric encryption. That the public key have to be authenticated, and it is extremely slow, up to like 1,000 to 1,000,000 times slower than asymmetric encryption, and it is far more computationally expensive, and the loss of a private key may be irreparable. You can lose your data forever if you lose your private key. Several notable applications of asymmetric encryption is HTTPS, Hypertext Transfer Protocol. Basically, what it is it's just an encryption layer applied over your website. For example, if you click on this clock icon on your web browser, you see the certificate of the website you are using, where you can see information like it is issued, the certificate is issued to google.com, and details such as you can view the public key of Google right here. Why is this certificate important? Because Google will not even consider your website. Google will not even display your website if you don't have a SSL certificate. Another application of asymmetric encryption is virtual private network and chat services like WhatsApp, Telegram, Teams, Microsoft Teams actually, and Slack. Alright, on to our final topic of today's presentation, hash function. By definition, hash function takes an input and return a fixed size string of byte. The string is called hash value. Hashing is not encryption. Encryption is a two-way process involving encrypting and decrypting a message. Hashing is a one-way process. Several popular hashing algorithms are the MD family, MD245, and the newer one, MD6, and the SHA family, 224, 256, and 5 trail. I can demo a hashing algorithm for you guys. For example, this is SHA 256 encryption. See, no matter how much I type, the string is always the same size. In this case, 64 characters. On to the weaknesses of hashing. One of the major weakness of hashing is hash collision with different gen of data. It is when different gen of data produce the same hash. One of the more popular case of hash collision is the encryption algorithm from the encryption algorithm MD5. But many newer modern algorithm has fixed this issue by increasing the size of the string, make it less and less likely for different chunks of the data to produce the same hash. Several applications of hashing is that password storage. Instead of storing your password in the database in plain text, you should hash your password before storing it. When user enter the password, you hash the user input and compare it to the hash inside the database. Well, another application of hashing is that you can verify data integrity. In some website, you will see the option to see a hash checksum hash. Basically, you can use that checksum to verify that the file that you downloaded has not been modified, or you can use hashing to digitally sign document and cryptocurrency. So this is the end of my presentation. Thank you for listening and hope to see you guys again.